A month ago, you may or may not have seen my video when I was talking about my book and how it led me to discover the hidden variable that Einstein was looking for. And I discussed it, and I also gave a possible proof for it. It took about 20 minutes, and I've had some good responses, and I appreciate it. But since then, I've also related my concepts of my books to the Michelson-Morley experiment. And if you look on the cut. So if you look at the 4.5-minute video by Neil Tyson, he'll explain the Michelson-Morley concept and how he considers that one of the best experiments of that century. And then I like to talk about it. And then, as long as we're here, just go a little farther to Einstein's relative theory that declares ether necessary. Now, that's going to be important because people thought because of the Michelson-Morley experiment was a null experiment, that there couldn't be any ether. But Einstein didn't agree with that. Anyways, the way I interpret this whole thing is that, yes, they didn't find the ether wind, but that doesn't mean there wasn't ether. They only discovered that there wasn't any ether wind. Now, how can I explain why there could be ether but no ether wind? Well, if you had a chance to read my book, you'd see that a space-time energy particle, of course, the original space-time energy particle was the complete universe, and then it subdivided and subdivided many, many times, and through inflation and everything, to give our larger universe. But the space-time energy particle is composed of two entities. One is the three-sphere cube, a cube on a three-sphere, and the other is the inscribed part, or the three-sphere is inscribed in the other cube, and they change places every Planck's tick, as I explained earlier. Now, how does the matter travel through the universe? Let me just show you what the universe would kind of look like. How would the space-time, or how would the particles travel through the universe? They wouldn't travel around the three spheres, they'd travel through them. They'd travel through them through wormholes. There's several different types of wormholes that will be discussed in the book, and by elementary particles traveling through the wormholes, that doesn't cause wind. It's smooth instead of rough. It's a smooth space-time universe. It's not rough like the quantum theory, and that's one of the reasons why we can put quantum theory and the general relativity together, as I explained in the earlier video. So there's a couple other things I want to say based on the fact now that the ether is actually what? It's actually the space-time energy particles. It's the space-time energy particles. That's what ether is. Okay? It's not nothing. It's space-time energy particles. So now let's move on to another category, and that is the pilot wave theory of the quantum realism. Now, this would be a good video for you to see because it's very important to me. I saw this video in December, just before Christmas, and if you want to take 20 minutes out, 15, 20 minutes out and check it out, I'm going to discuss the details. Okay. So after reviewing that video, I got very excited, and I got so excited I packed up my 2 books and sent it to Matt Dowd. O'Dowd, sorry, Matt. Anyways, Matt, I sent that to you, and I had it so that you'd sign for it, so I know you'd get it. And I did get your what I think is your signature, saying you did receive it, and that I know that you were talking about the theory and how it had potential, and I thought I'd help you out. I'd show you how this theory could be improved, and I could prove or show that the what the hidden variable was. And I thought maybe you'd get excited. But like I said in the other video, I've heard nothing. Come on, Matt. Get on the ball. Give me some feedback. Tell me what's wrong. I need to know. Now, you're a scientist, and you push the idea that all roads have to be looked at, all paths have to go down, and we have to figure out how this great universe works. And you are an expert. You're one of the smartest guys going on these videos today. Okay? Thank you.